Hey, thanks for listening to the Welding Tips and Tricks podcast. I'm Jody Collier.
I'm Roy Crumrine.
And I'm Jonathan Lewis.
If you're new to this podcast, one of the things we've been doing is every other episode we've been interviewing a guest. And so far they've been from Instagram, and probably they largely will be from Instagram because that's just where we hang out and where we see people posting interesting stuff. So one such person that posts a whole lot of interesting stuff on a lot of aluminum welding, a lot of really thin wall stainless steel and things like that is Rush Kane. He's Kane Kid on Instagram. Thanks for being on, Rush. And one of the first things that I want to kick off talking about, and I think everybody will be interested in, is you use something called active gas for TIG welding. Could you give us a little heads up on what it does and what it is?
Yeah, thanks for having me on here. So the active gas welding, instead of being a total inert gas like running straight argon, it has oxygen that's in this particular gas and a small amount of nitrogen and hydrogen. Those gases make the aluminum react differently than in a total inert environment. With the nitrogen and hydrogen, they'll help the arc burn hotter. It kind of can eliminate the preheating, and it'll allow your arc to start out really stable, burn more fluid off the start. And then it has the oxygen, so when aluminum is exposed to the oxygen, it hardens the weld faster than when it's totally encased in that inert environment.
That sounds pretty cool. And one thing I saw, you just recently posted that you're trying that 4047 wire. How's that working out?
Yeah, it's a pretty cool filler rod. It has nearly double the triple amount of the silicon content, and it has added magnesium in that filler alloy, and it flows really, really fluid. It has a really, really glossy, shiny finish to it. The reason I was trying that rod out is to see if it will help naturally fill craters at the stop of your bead and kind of eliminate the porosity in your aluminum welds.
How do you think that rod's working out for you so far?
It's been a pretty interesting rod. I haven't had much experience on it to see how well it holds on pressure testing and helium testing. So I'm still waiting for parts to weld so I can see how it goes with those.
I like that rod for aluminum castings. It's funny, it's actually termed in a lot of cases as a brazing rod for aluminum because it melts at about 100 or 200 degrees less than the base metal of it's a little bit lower melting point than 4043, just enough that they call it a brazing rod because you can actually weld a fillet, like say, hypothetically, you weld a fillet on 16 gauge aluminum with 4043 and you cut and polish and do a macro specimen on that. It looks almost like a solder joint. You can flow it in there where there's absolutely no depth of fusion, but it's bonded, just like a braze joint would be. And so it is a little weaker on its tensile properties than 4043, but a lot of times it's good enough. And like if I was patching a crack on a crankcase on a Harley that was polished aluminum, I would grab that because it'd be a lot less likely to have porosity when it polished out.
I'll have to look into buying some of that and have it in the arsenal of wires.
It's interesting to weld with, too.
It's like water, ain't it? I mean, it flows, it wets out.
Yeah, it's
like...
You have to dab fast.
Mm-hmm.
Is it more like a silicon bronze type of wetting out?
I haven't ever tried that, so...
I'd say if you were going to compare silicon bronze to ER70 steel wire, then yeah, it kind of wets out that much better than 4043. It goes in the opposite direction than like 5356 as opposed to 43. It kind of goes in the opposite direction as far as wetting out better.
Wow.
It's like 12% silicon, and that makes not only the melt point drop, but it makes the solidification range broader, and that's supposed to help with cracking, in highly restrained joints. Again, doesn't have quite the mechanical properties, but for a lot of times casting repairs, you don't wind up with the same mechanical properties anyway. Much less likely to have porosity than 4043 or other rods. Well, I'm going to circle back around here from the 4047, which was interesting stuff, and get back to the active TIG gas. Rush, have you ever used a helium mix? And if you have, how would you compare it to the active TIG gas?
So I've used helium mix specifically on titanium, and I haven't used it on anything else, any other metal except for titanium. When I use the helium mix, I was purge welding the backside, I think, with 10% helium argon mix, and the top side with 15% helium argon mix.
Mm-hmm.
Opposed to straight argon, it helped bring the extra heat that I needed to make a full penetration weld,
right,
and keep it shielded properly.
Okay. So you haven't really done a whole lot of using helium mix on aluminum? Is that what you're saying?
I haven't.
Okay. Well, so we don't confuse anybody, I'm guessing that it must have a pretty small percentage of oxygen. But, it's not like they just put some in there. It's very controlled when they mix it from the factory. It's very controlled. They've done a lot of testing on it and all that stuff. But you say it eliminates preheating in a lot of cases. And for me, that's kind of what using a helium mix does, where me and Roy both kind of just mix it to what feels right. We use a Y, mixing helium in with the argon, and just barely crack the helium till we get the puddle in the arc that we want. So they have mixers out there, I know, but and also I have a pre-mixed, bottle of like 20% helium, but it helps again with preheat. Like it puddles immediately on most stuff unless it's super thick. The more helium, the quicker it puddles on thick stuff. So is that kind of what the active TIG gas does for you?
Yeah, it's exactly what it will do. And it also helps with the etching line alongside of your weld. It helps keep that to a minimum since it has those active gases to help clean the metal instead of making that arc work for it.
Now I've used Blue Shield, which is 95 argon 5 hydrogen for welding stainless. And one thing I noticed with that is it throws a really big flame off the end of the arc. That you get that same flame that comes off of that with the active gas?
Yeah, I noticed that when I was doing a recording and I was burning my hand off. After I looked at the recording, I saw about a 3 to 4 inch flame shooting out of the end of my torch.
Yeah, they'll get you too. You don't see it when you're welding, but boy, you can feel it.
Oh yeah.
There's something about mixing hydrogen and argon that just doesn't sound right,
Yeah, no, it doesn't.
I've done the same thing. There was some Inconel, which is a nickel-based alloy, Inconel 718 casting test that recommended 5% hydrogen. And actually it helped a lot because, what the hydrogen does, it actually burns, and so any remainder of oxygen that's in that arc plume will burn up, basically, and so it provides a reducing atmosphere there. And it just wets out a little bit better, and man, just that little bit sometimes makes you be able to wet out with less amperage. We're talking details sometimes to get things like, in Rush's case, passing it with a helium leak test, but also maintaining the mechanical properties of the base metal, whereas if you use too much heat, you lose those properties. So he needs to be able to puddle real quick and weld it, and also not have a crater hole when he gets out of there. So a lot of the stuff that Rush does, it not only requires passing a helium leak test, and of course a visual test, but he's also got to maintain dimension and then maintain mechanical properties of the aluminum as well. And if you put too much heat in and have to wait around for something to puddle, you start to lose mechanical properties with a wider heat affected zone and all that stuff. So these things like a little helium mix or active TIG gas can make a lot of difference for critical parts. And since I mentioned that, all that stuff, that brings me to the water-cooled fixture on that part. Can you talk about that a little bit, Rush, about the ins and outs of that part? I know you've got tight dimensions on it and stuff like that, but give us the rundown on that and why the water-cooled fixture.
Yeah, so there's this 6061 T6 part that I weld, and it needs to keep like a 2000s tolerance on dimension, and it needs to stay within temper, because when it's overheated, it turns too soft. In order to keep it that way, there's this machined out kind of negative of the parts that I'm welding. They have cold water circulating through them. And so when I weld the parts, they're encased in this fixture. It's constantly circulating cold water as I'm welding it. And I put that in a positioner and spin those out while they're cold. And part of the 6061 is about a ½ inch to another part's about 5/8 thick of a solid machined out chunk of aluminum. I've tried welding those with straight argon, and that's where the active gases helped with that.
Yeah, I can imagine. I'm just sitting here thinking about putting something in a fixture with chilled water running through it. I mean, it's hard to get a puddle going on something like that without just romping it, and waiting around for a long time. And, aluminum, it's guys that do a lot of testing to prove out procedures. They know that it's always a battle between maintaining mechanical properties and porosity. It's always a balance. You got to get an acceptable amount of porosity, which hopefully is none, but You know, sometimes there's some slight amount allowed depending on the application or the code, but then mechanical properties come in. If you get it welding so that you have no porosity, where everything's nice and hot and flowing really well, then you lose your mechanical properties. So that's where the helium mix and things like active TIG gas can really give you an edge as opposed to straight argon.
Yeah, and I'm curious too, with the chilled water, is it running through just like a water cooler for your torch, or is it running through like a Freon chilling system of some kind that actually is making the water really cold?
Yeah, so it's the designated chiller that pumps and circulates. It's really similar to the one that hooked up to your TIG torch, but it's a chiller machine that takes distilled water. It cools it down as it circulates, and so the water, I think, is running between 35 and 40 degrees.
Nice.
That's circulating through those blocks.
Wow, that's sucking some heat out.
Mm-hmm.
So you probably, after 30 seconds or 45 seconds, you probably lay your hand on it with that water circulating through there.
After the welding's done, they're still a little bit too hot to touch barehanded, but about a minute and a half after, you grab those barehanded. They'd be a little bit warm, but it starts to cool them down really quick.
And like you were saying, there's two different fixtures. There's one it goes into, and then there's like a slug that you put on the inside. I remember seeing videos of that and thinking, you know, wouldn't that get stuck in there after being welded? It shrink down onto it, or does the chilling keep it from shrinking that much?
Yeah, because there's only, I don't know guessing the dimension of the play in that. When I put it in, there's probably about 5,000ths of play, probably, when I set that in to that slug part that you're talking about.
Mm-hmm.
And then when I pull it out, maybe a little bit less, depending on how hot it is. But that's the whole purpose of those, keep that tight tolerance of the shrinking and expansion.
I think it would help everybody. We're assuming that everybody's seen this part like we have, because we all look at what you post. But if you haven't been on Kane Kid's Instagram account, you'll go on there and do a little perusing, and you'll see a round part with a couple of water ports coming off of it. There'll probably be more than one post on turntables of that particular part, but it's a really interesting little affair. That's what we're talking about here, is this particular part has really tight dimensional requirements, as well as trying to maintain the temper of the aluminum and not just anneal it and make it too soft.
Another cool little gadget that we see you using on Instagram a lot is that corner fixture. It looks like it just kind of goes on the top of the outside corner joint, and then you traps your argon there a little bit, or gives your hand somewhere to rest on it. Can you give us a little insight on that?
Yeah, so I run a lot of outside aluminum corners on 063 aluminum, and I have this jig. It's a clamp, and so it has aluminum on the backside for a heat sink to keep that thin gauge aluminum from warping, and then it has a stainless clamp that sits on top of it to hold it down and hold it together, so I can set my edges exactly how I want them to be set up for the weld. Then I have a little hand slider that I'll use to stay steady. So that just allows me to weld probably 70% faster than if it was just an open corner on some aluminum. And then it keeps all the warping out and keeps me perfectly in position for repetition on production parts.
That's pretty cool.
I've copied it.
Mm-hmm.
How's that working out for you, Jonathan?
I've only just copied it. I've never actually really used it for a part.
Well, when you do, let us know.
I will. I was just trying to be cool, you know?
Now, one of the reasons we have the guests on here is we are always really interested in hearing the backstories of where everyone we follow on Instagram has come from and all. And if you wouldn't mind, Rush, giving us a little insight on your backstory and how you got into welding and what got you where you are today.
All right, well, how I started out in welding was, I didn't even expect it. I didn't even see it coming, really. So my mom was a jeweler. She did like oxyacetylene welding and soldering on gold, like doing gold rings and stuff like that. And I always saw, like from the time that, or at least I can remember, seeing my mom making jewelry and repairing jewelry. And I never really was intrigued by it, but it was interesting to me, besides it was dangerous because it was fire. And it's funny because that's not what got me into welding, but what happened when I was probably 13 years old, I was watching music videos on MTV. I saw this video that had these guys riding around these custom bicycles, like lowrider pedal bikes, kind of choppered out. And I was like, those are so cool. Like, I want to make one of those. And I was going through high school registration, and I was like, I saw welding on there, and I was like, you know what? If I took welding, I would probably be able to make one of those bikes. And so I signed up for welding. They sent me to the technical school, like the city technical school, instead of high school, because the high school class was overbooked. And so I went to this other class, which actually worked out greatly in my benefit at the time, and that's where I started welding. I started out going through the stick welding course, and then the MIG welding course, then the flux core course, and then I wanted to learn how to TIG. I completed everything up to that point by the end of my second year, I think. And my third year, I was like, hey, I really want to learn how to TIG. And my instructor told me, he's like, well, let's try out the oxyacetylene welding first, see if you're able to do that, and then I'll let you go use the TIG machine. So I went through that course on the oxyacetylene welding and brazing and completed that. And then I was like, hey, I want to learn how to TIG. So he showed me how the machine worked and everything. He kind of ran a little weld. And I was like, oh, that's interesting. So that's really what I wanted to learn, because it was the most technical part of welding that I knew of, and it required the most skill. And so I was determined to learn that. And jumped on the machine, didn't really know what I was doing, and practiced, tried different things, found out what worked, what didn't, and played around on that machine for about a year and a half in high school. And that was my basic TIG experience up to that point.
Well, that's pretty cool. Looks like you're got it figured out now.
Since then, I've had a total of probably 10 years TIG experience.
That's good.
10 to 11 years, and it's been really fun. A lot of really good on-the-job knowledge and training.
From your posts on Instagram, there's one guy says he's got 10 years experience, and it's way different than another guy's 10 years, because it really matters on the variety of work that's thrown your way. And if you're doing, like, say for instance, and not to knock anybody, you can't help what's thrown your way a lot of times, but you got a really good variety of jobs that you post. A lot of aluminum, a lot of turntable aluminum parts, but then also a lot of really thin wall, small diameter tubing, end caps on tubing and things like that. And you also posted recently on some different tungsten preparations on the different angles of different tips and the effect that they have on the arc. So since those two relate as far as needing a really stable arc on those real small diameter stainless parts, let's talk about that just a little bit. Let's talk about the electrode prep. You posted kind of recently some different arc plumes coming off of a 25 degree, a 35 degree, and a 45 degree prep. I know there's the textbooks show you something very similar to this on penetration profiles, but how does that relate to like those little thin wall stainless parts that you do?
Yeah, so with my tungsten prep, I have a dedicated diamond wheel tungsten grinder that I grind with. It puts pretty much the exact same point of whatever I want. I can repeat that anytime I want on my tungsten. I don't know how common of knowledge it is. Like, if you look for it, you can find it out, but how your tungsten grind angle and the type of point that you put on it, how it will affect your arc. It's something that it really does affect your arc, and you can use it to your benefit in different situations of manipulating your arc to the type of weld that you want. So on the thin wall stuff, so I do the thinnest material I weld on is 6 thousandths wall Inconel and 8 thousandths wall stainless steel.
Pretty small.
Prepping those, I'll step down to 1 millimeter or 0.40 inch tungsten. I like using the 2% lanthanated. I recently got a pack of the laser alloy from CK because it has a really good repetitive start and a micro arc start capabilities. I've yet to use that alloy yet, but the 2% lanthanated I've been a big fan of so far. And it seems like a harder tungsten. It's more heat resistant than some of the others. For that small thin wall stuff, I like to put about a 20 to 25 degree long taper. Because I don't want it to melt the metal away. I want it to kind of fan out and since it's such a small material to work with, I want it to be as easy as I can. And since it's going to put a more shallow weld, I'm not going to blow that tube out so easily. It allows the weld to fan out so I can see it more, because I don't use magnification or anything to weld those. I just hand turn them across my table, and it allows me a little bit more ease to complete those welds.
Yeah, and this is another thing, too. If you haven't seen these little tubes that he's talking about, you need to go onto his Instagram page right now and check it out. When he says they're small, they're small.
Yeah, it's good that you put a dime next to them for a frame of reference, because everything looks big on Instagram. You know, some of the stuff that you do, when I read the dimensions of it, I'm like, holy crap. And I just thought to myself, holy crap, too, when you said you didn't use any magnification on that 6 thousandths. Because those days are gone for me, man. Believe me, I got to have some magnification on anything close to that. That's for sure. So you're using a 040 2% lanthanated electrode with about a 25 degree taper on it. Typically, you use a Miller Synchrowave 351, is that right?
Yeah, that's what I work with.
So that's got a good enough low-end crisp start to do that stuff with, I would imagine. Otherwise, you won't be able to do what you're doing. But I'm kind of surprised at that. I've used that machine a time or two, and I never, I know they're all a little bit different, but they're all the rage is, the inverter machines, the Dynasty 280 and the 200 having a 1 amp start, advertising a 1 amp start, and they advertise that. It's a lot of that stuff is a little bit smoke and mirrors because it's not only the amperage but the time of the amperage, and they're able to advertise a 1 amp start. Whereas a transformer machine like that, it's a little different. But anyway, it's impressive that you're able to do those tiny little thin wall parts with that machine.
It's a really good machine, particularly the one machine that I run, and I spent a lot of time with it and learned a lot of how to work the machine too, and how to work my foot pedals. When I weld those little parts, I usually rarely turn my peak amperage on my machine to less than 100. It's usually set between 100 and 130 amps.
So you have it at 130 amps for 6,000 wall tubing.
I'll usually back it down to 100.
Still.
Because it gives a little bit more room. Just a little bit of footwork, and being in tune with the pedal, with your foot. Because it's not hard. Like, what if your amps, like, if they're going to start out at, like, if you're going to start out with 10 amps, you just need to make sure your arc starts where you want it to.
Yeah.
Because you can pick up and run with it from that point. Like, you're going to start at a sprint, but you can weld that thinner stuff if you have a fast travel speed and if you know how to work with it. It just takes a little bit of time to figure it out, and then from that point, it's not so bad once you know what to do.
Do you do the scratching the tungsten right where you want to start the weld at?
Yeah, so I had a video I posted a while back of that. I just I try to just dig the tungsten in right and give it a fresh point where I want it to start. My theory behind it was no matter how long your metal's been sitting there, it's going to have some sort of surface oxidization on it, and just try to remove that, because that's where the arc's going to want to start.
I agree. I also think electrons don't want to come off a flat surface, so if you just scratch it a little bit, if you were to look at that scratch under really high magnification, you would see it's really disrupting the surface, even though it's just a tiny little scratch. And that provides a path for that arc to jump off of, and it really does help. I do it all the time. I know Roy does too.
Yeah, that's a habit I got into with when I was working in that shop with that Blue Shield gas. There's so much soot on the part and stuff like that, you just scratch it and it would just burn right through it.
I think it's good too on your tungsten, because your tungsten, when you're using a high frequency start, especially on a synchro it'll kind of frost your tungsten,
right,
where it looks like you sandblasted the end of it, and it gives it a nice clean point so it doesn't have to work through that frost.
Right. One thing I remember a post a little while ago, you had one of Jonathan's indestructible cups. You were able to get some pretty nice looking welds out of that thing.
Yeah, so Jonathan sent me one of his Superior Tig Welding cups. It's machined out of aluminum, and said it was rated up to 150 amps for a short period of use. I think, was that your parameters?
Yeah.
So I've tried to stay within those guidelines and use it, and it's been, opposed to using an aluminum number 8, that Superior cup I've been really impressed with it. I welded I did an end cap on some Inconel tubing, I think it's 1 5/8 OD, and then put an end cap on it, purge welded the inside, and usually that weld would be kind of a little bit hazy, and I went around the turntable, put on the turntable, went around it with that cup on the outside, and it came out nearly colorless. I've never had that before.
That's pretty awesome. Just curious, what type of industry do you work in?
So I work in a precision instrument and calibration industry. I'm working in manufacturing components that go into test equipment, and so along the lines of like that thin wall tubing being a thermometer sheath, and so a thermometer will have sensors inside that, and it's a protective covering for those sensors.
Well, that's pretty cool.
That's interesting.
I want to back up just a little bit because I'm not sure everybody grasped what you said earlier about welding those small, some of those end caps on the small diameter tubing. You say you just basically rolled them by hand on the table while you fuse the end cap on?
Yeah.
Okay, that's pretty impressive, I gotta say. Because, again, people listening, go check the post out. Just some old small stainless and Inconel little small pieces of tubing. It was at like 035 wall, and some of it even a lot thinner. But
on the little thin wall tubes, so those are all purge welded too. That's a struggle too in itself. Getting the flows right, getting the right CFH on the inside of the tube and the right CFH on that coming from a torch. And to purge the insides of a tube with that thin of wall thickness, I'm running about 2.5 CFH on the inside and about 10, like 7 to 10 on my torch.
Yeah, and that's a big deal too when you get down into that thickness. You're not only, like you said, you got to balance out purge gas and torch gas, but generally a low flow on the torch is going to help a lot on that small diameters and thin wall stuff. And so that means you can't be sticking your electrode out an inch and things like that with that low, because you don't want turbulence in the gas. You got to have a soft start, and that blast of gas coming out of there just does something to the arc starts and everything. So I just wanted to make sure everybody understood that you were hand rolling those things out on a table, and some of your stuff is on positioners and everything, but to me it's just mind-boggling to look and see what you're doing hand rolling on a table like that.
Yeah, when I hand roll those, I have a piece of nylon that I'll use as kind of a backstop that I'll push against.
Okay.
So it helps it roll a little bit better. It's still sitting on the top of my aluminum tabletop, but I'm rolling it against a piece of nylon just to help it not get hung up and help it roll smooth.
Yeah.
Along those lines, you also have little tubes that have sunk-in welds where your weld is recessed. Talk a little bit about the hows and whys of that.
I'm trying to think of what you're talking about. Is it?
You show where the weld is sunk in, like you're joining two pieces together. And I know you've taken pictures looking down inside of them, or is that the cap? I'm not really sure. I'm looking at your page right now, and I'm looking at a post that's showing like a whole row of them with the welds in the middle of the tubes that's sunk in.
Okay, so on some of the things where I have, so those are dissimilar metals that need to have a visible joint, and so that's one of the tubes. So that's a 3/16 OD 1/8 inch ID tube of nickel and stainless, and fuse welding the nickel to the stainless, and I need to have a completely full penetration weld. It calls to be concave on the outside, so there's a visible point of where the nickel and the stainless are in that tube, because both ends of those tubes are used for different applications.
That's interesting.
Yeah, that is very, very interesting.
Didn't know that. That's interesting.
Yeah, one thing that kills me when I look at your pictures of a lot of the aluminum outside corner joints, you always say you have to grind those off, and it's like, no, why would you grind that off?
Yeah, that's the biggest bummer about that. And so rarely ever do I get to leave just the dimes of my aluminum welds on the parts that I do.
So sad.
But that's...
Go on Instagram.
Yeah, you gotta let them live long on there.
At least you got that,
And one thing with making such a nice, small, even, smooth bead, it comes off when you're grinding it. It probably just zips right off without any problems.
Yeah, that was the biggest thing for me to get to the point where I needed to be able to produce a really, really consistent weld that was really small, is I had to go grind it off and imitate a bend radius on my welds. And I don't like spending time in the grinding room with grinders and sanders. It's just not what I like to do. So I was determined to make myself be able to produce the type of weld that was easy to grind off and sand, that would still look really, really aesthetically pleasing, save me the time doing the stuff that I didn't want to do.
It's a shame that they have to get ground off, that's for sure. But it's food for thought, because there's probably a ton of jobs where if the welder had to, at least for a while, had to grind his own welds off, it'd be some really good training. And you'd be on the incentive plan, to make sure you were putting the right contour weld on.
Oh, yeah. I know that from personal experience, too.
So, Rush, let's talk about on your Instagram page. I see here that you make some sweet jewelry. You said your mom was a jeweler, or is a jeweler, and you've made some rings that are just awesome. And you posted one a couple days ago, or about a week ago, from us recording here. That's just, it's beyond anything I've ever seen. Those are just awesome.
Yeah, so I've made a couple rings before in the past, and then, or I think it was late last year, I was contacted by this guy that he's like, hey, I know that you're a TIG welder and you can work with really small, precise welding. My daughter wants this ring. She wants it a certain design and style, and would it be something you could do? And then he sent some pictures, and I was like, absolutely, I can do that. He's like, all right, well, we want you to do it. I was like, oh, okay. And then I was like, oh, well, I'm going to figure out how to do it. I made this double band kind of wire frame, hammered finished engagement ring, and then I set it with a clear beryllium crystal instead of a diamond, and they loved it. It was a really fun thing to make. I posted that on Instagram, and then I had some contact about that ring, and somebody else wanted one. If somebody who I was friends with, they're like, we want you just to make whatever you decide, like judging off our personalities, we want you to make this women's ring on your own interpretation of that. And I made this other one, and it was really, really fun to make that one too. It was really, really small. It was a size 3 ring finger. Really, really small. And then a couple weeks ago, my friend said, he's like, I'm ready for my men's ring. So just whenever you get around to it, just keep that in mind that I'm ready for it whenever. And so I buckled down and checked that ring out, that men's ring that is the one you're talking about.
Mm-hmm.
That was one of the funnest things that I've made.
How'd you come up with the design on that?
I took like a Post-it note and sketched a couple different ththings out, and that was the one that I liked.
It's different, you know? You call it the abstract alternative men's band. It's just neat. I mean, it might not be for everybody, but it's definitely, neat looking.
And so I kind of judged it off of his personality, what he wanted. And so he does some work in the entertainment industry, and then he does work in the construction industry. I thought it'd be cool to have something that kind of matched both of those worlds, and that's kind of where I brought it together with that ring on the design.
It's very cool looking. It speaks to me. So if you ever want to make another one, it is. No, it's the I don't have that gene in me that apparently it skips a generation because all my kids are very artistic, but I'm just practical to a fault. So I would be like, yeah, cut a piece of pipe, polish it up, it's good to go, But you got angles and different, not even really what you'd call round, and it's just really cool looking.
If you look down your finger at the kind of from straight on from your fingertip towards your palm, kind of that shape of your finger, that's what I made it after because it's more comfortable than a round. So like when you have a closed hand and your fingers are next to each other, you don't have that ring binding out and pressing out to your other fingers.
It's cool looking. That's all I know. It's awesome.
We'll give you a plug. If anybody wants to order one, just email orders@rushkane.com.
Yeah.
Another thing that we've all noticed with a unique thing that you do is the way you feed your wire. Definitely have a unique 2-finger push thing that I've never seen before, and it seems to be working very well for you.
Yeah, so it works really, really well for me. I haven't seen really anybody else that can pull it off. I've heard of a few people trying it after they saw that same technique. But I tried some of the other, like, more common and similar, like, what other ones where you use kind of your thumb to push the wire through, and these different feeding techniques. And I tried those out, and I tried them, and I couldn't get my hands to work that way. And so I was playing around with the filler rod, and I was like, what's the way that I'd be able to keep this wire moving so I can constantly feed my weld? And that's what I came up with. Been doing it ever since.
Yeah, I haven't really tried it, but I'm watching you right now. I'm watching the video on one of your posts, and the first thing that jumps out at me is that your hand is in a perfectly natural position. You're not having to be uncomfortable at all. Your hand's upright, and it looks like at the end of the day, you're not going to be fatigued from doing it that way. That in itself is worth taking a look at for people, especially if you're doing positioner work like you're doing there. And, you got one elbow, torch propped on a prop, and the forearm propped on something else. It looks like you're comfortable as all get out, and just pumping the wire in there. So lots of ways to skin a cat. And I encourage anybody listening to this to go check out. It's Kane Kid with a K, and just a lot to learn by watching the way he feeds wire.
Another thing too that I know I've noticed, and probably everyone else has too, but you've got a large black cushion thing on the top of your torch. What's that all about?
Yeah, so that's exactly what it is. Is on the back of my torch tail I have it's a piece of foam rubber, and it's like I don't know if it was like a gardening hose or something, like for a water line for a sprinkler system. I don't know exactly what it was, but I came across this piece of foam and slid that on the back of my torch tail, because when I was doing that thin wall tubing, I'd kind of hold my torch on the cup and my fingers would just dig into my torch tail, and I had these bruises on my knuckles almost to the point that they were bleeding because I couldn't loosen up on the torch, just trying to keep it so stable. I was like, what the heck is the matter with me? It's like, I gotta loosen up, and I couldn't loosen up, and so I threw that piece of foam rubber on my torch tail and just left it on there ever since.
Yeah, it seems to be working. I might give it a try.
Some of that neoprene perforated leaky water hose or something like that. It looks like it's something like that, but whatever works. That's a good motto.
Kind of going back to those active gas parts and stuff, you said that those get tested with helium. How do they do that? Is it a vacuum, suck them down, and then you wand helium around it, and you have a machine that smells for the parts per million?
That's exactly what it is. So I do both a negative vacuum test and then a positive pressure test, checking those parts, because you'll have different types of leaks at different pressures. But typically it's a vacuum test where we'll put a negative pressure on the inside of the part and then spray it with helium wherever the leak is. It'll suck it in through the part and into the testing machine, and it'll sense the helium and sense the leak rate of the helium.
Yeah. How would you find your hole with that then?
Flow of your helium, you can kind of pinpoint it and test it, because helium's going to go up, and so you can kind of twist your part around, aim it at different spots to kind of target the zone where it's coming from. And then taking the helium, you can tune it down until it's basically just dripping out so slow, and you can put it around your welds and it will pinpoint exactly where the leak's coming from. And sometimes it's not even visible, like you can't physically see where you have a leak. It'll be leaking, and you just have to trust that it's leaking and go fix it and hope for the best sometimes.
That's not something I get into, so that's interesting.
It can be really, really frustrating sometimes, and I'll weld these parts, and I'll weld them at 100% pass rate first go, and other times I'll be at 20 to 30%. It can be really frustrating.
Yeah, I bet. And then going back over your weld, do you grind the weld off and then re-weld it, or do you just go back over it again if it fails?
So I usually just go back over the weld, because when I put the grinder to the aluminum, it puts so much more contamination than there was to begin with.
Yeah.
And it's really, really hard to get a better weld after that point. And so I usually just try to go back and weld through it. Usually I'll put like a cap weave over a stringer where it won't matter if I have the extra buildup. That seemed to help me with stuff like that. Other times it's just working the material until the contaminant boil out and burn up.
Yeah, with having leaks and stuff like that, kind of brings a question of what type of stresses do you have at your job?
I don't know. I try to eliminate the stresses from me personally, but one thing that's stressed upon me is top quality but still be productive, and I feel like both of those things go hand in hand too. Yeah. A lot of the stuff, like what I focus on is welding preparation. So in order to get the weld that I want, usually it's about like 90 to 95% weld prep, and then the other 5% is welding, and then at that point the welding is the easy part.
Anything other than an acetone wipe? What's a typical cleaning procedure for, let's say, aluminum jobs that you do versus stainless?
So on aluminum, typically like a raw rolled sheet of aluminum that has that surface oxide on it. Depending on what it is or how deep, you can kind of see that goldish tinge on aluminum. And you don't really notice it until you brush it off, and then it looked like a blue metal to yellow metal, kind of, on the extreme side of things. So typically just either wire brush that off and then wipe it with acetone, or it gets ran through a sander. If it's not an old sheet of aluminum etching from the art on the welder, if it's not too bad, we'll just remove it good enough. Mm-hmm. If not, then I'll take like a little, like a piece of Scotch-Brite, or just like a little, like the toothbrush style stainless steel brushes.
Yeah. And
run those along the weld where I'm going to weld. Remove that off, acetone it, fit it up, and ready to go. A lot of the stainless steel I weld is a 4B finish, and it comes with the plastic protective sheet on it.
Mm-hmm.
A lot of the times, just peel back the plastic, and if it's old, then it has a thick residue. But if not, then just usually go with it and see how it goes.
Okay.
Now, you had said earlier with your favorite type of work is aluminum. What would you say your least favorite type of work is?
I don't really have a least favorite type I can think of besides anything that's zinc plated or galvanized.
Yeah, that's terrible. I hope no one
But
really enjoys welding galvanized or, zinc coated stuff. That's just awful.
Yeah, it takes all the fun out of it.
Instantly ruins your tungsten.
It's hard to get anything going good on galvanized. In one of the fab shops I worked in, they did quite a bit of galvanized pipe, and even though the coating was removed before welding, there'd always be a little bit left over. That cover pass would, on the toes of the weld, would bring it out.
On those motorcycle oil filter cans that I was welding, they were supposed to have a raw steel washer that got fused onto the top, and every once in a while there'd be one that was galvanized. And you couldn't really tell until you struck an arc on it, and it was like, oh, man.
Yeah.
It's all, the puddles just jumping all over the place as it's going around, and it's like, come on, they're all just mixed into the bag. They ordered it from McMaster or wherever, and you just get what you get. A little surprise.
Yep. It's like the rat hair and the peanut butter. They're allowed to have a certain amount, apparently.
You kind of mentioned it in passing, that little hand slider that you made. And this has been back a long time ago now since you posted that. I encourage everyone, first off, to go through his page and find it. I'm looking at the computer now. It's 44 weeks ago you posted pictures of this. Describe that to the audience and everybody listening there and what you really use that for.
So I made this little palm sled device. It's basically just a 90-degree angle, and it has some nylon plates on it, and the plates are mounted to this little piece of angle, and it has kind of a little stem that you can hold on to, and it allows you to put that on the edge of your table, the edge of a piece of angle iron, even on a piece of round tube, and you can set your hand on that, and if you're welding in a straight line, you can glide your hand on this with minimal friction and keep a really steady and consistent motion with your torch and keep that constant momentum, help stabilize and create a nice looking weld.
Do you end up still using it very often?
I don't use it very often, but there's been certain times that it's just handy to have around. Years ago when I was starting out, I would have used it all the time, but I usually don't think hey, I need to grab that to help me out. One thing that I do have that I use a lot alongside with that aluminum angle clamp for the outside corners is I have a piece of flat bar. So in the videos and stuff, you'll see outside corners on aluminum. I'll be sliding my hand along this flat bar, and that has a nylon plate on top of it, and it causes really low friction with my welding glove, and I can just keep my torch hand dragging really, really smooth and consistent off of that, which essentially does the same thing as the little palm sled.
Yeah, it's little things like that, paying attention to little details that make things night and day, where you're sliding your glove on something or on your table and it snags on a little burr on your table, and it's like, well, you either got to pull past it or you got to just, stop and unhook your glove.
Yeah, it's a handy tool. I made one after you'd posted pictures of that. I made a slightly different version of that. I've used it for several specific projects, but it's just kind of one of those tools on the shelf to use one day. I thought it was a sweet idea.
It ended up not being something I use all the time, but every once in a while it comes in handy.
In the beginning, you had mentioned a bicycle that you saw on MTV. Were you able to ever make one of those bikes?
Yeah, I started out in welding my freshman year, and I was like, hey, I want to do this project. And typically, only seniors were allowed to have a welding project. And I really wanted to do this, and my welding instructor's like, you know what, if you finish the first year course, if you finish it early, then they'll let you do a project. And I was like, oh, that's really cool, I'm going to do it. I'm going to finish all my weld tests and complete everything so I have time to do what I want to do. And I wanted to build this bike. I started out in welding, and I was probably the one person that was the furthest behind on assignments and passing off weld tests in the whole class because I didn't understand welding. Everybody was just passing me by, and then finally something clicked, and I took off, and I was able to finish everything by the last quarter of the year, and I was able to start my project. So I got this old bike, I think it was an old Schwinn bike. I went and picked up for like $20. I picked it up, chopped it up, kind of stretched out the frame with solid tubing, or solid stock, like half-inch round, and one part of the bike was 1-inch solid square that I heated up and twisted back and forth. It was so heavy. Ended up being about 8 feet, 3 to 4 inches long from the front of the tire to the back of the rear tire. It was a fun bike. I rode it around. It had big stretched out 8-hanger handlebars and a Springer front end suspension on it.
Sounds fun. That sounds like a lot of fun.
It was a fun project.
One thing you had said when you were talking that you didn't really understand welding. Now that you are definitely on the more mastering side of it, what would be some good advice that you would give someone that might be in your same situation that you were, when you were in school and you weren't really understanding it, or just a good advice to somebody that's learning or wants to up their game?
Well, starting out, the setback I had, I didn't realize, like, even though it was called arc welding, I didn't realize, like, hey, this is an electrical circuit, and there's a short in the circuit. Like, I'm creating a short in the circuit. I'm completing the circuit, but creating a short, and I'm controlling that point in the electrical circuit to generate heat to bond all these separate pieces of metal together. I didn't realize that. I thought I was just melting metal onto metal. I didn't actually understand, like, hey, this is the whole basic concept of the process that I'm trying to do. It took me 2 weeks before I was even able to strike an arc with a stick welder, mainly because I wasn't able to grasp that concept because I didn't understand it. Once I figured that out and realized that actually what I was doing, a lot more of it clicked. And from that point, it was just practice and trying to figure out exactly what I needed to do to manipulate the arc and the metal to get it to react how I wanted it to. It's kind of like somewhat of a intuition that you have to gain with the metal to really understand it. Like, there's certain things you can do and can't do, depending on what the situation is and what the metals are going to allow you to do. And just paying attention to that is one of the biggest things, I think.
It sounds to me like you just kept thinking about it, just like solving a puzzle or whatever. A lot of people don't stick with it and don't really dig in deep, try to solve the puzzle, and figure it out, or the riddle or whatever, and they move on to something else. They figure this must not be for me, but I know there's been plenty of things along the way that seemed like they were going to really kick my butt, and did for a while. Finally figured them out. And then the more things you figure out, the more confidence you get that you'll figure the next thing out. And it's just kind of like you get some momentum going, and then you take off. It's what sounds like what happened to you.
I think that's one of the fun things about it, too. You're never going to know everything about it. Like, you can listen to what's out there, learn and build on that, too. But there's pretty much no limit to what you can learn from it and the point that you can progress with it, from my perspective, anyway. It's just unlimited amounts of continuous improvement that if you put your drive to it, then that's what you can do.
What would you say was some good advice that helped you along the way from somebody else that might have helped you out?
Like, if you like it, stick with it and find out the way to do what you want to do, like the way that works best for you.
And that's really the key part too, is that's why I tell a lot of people that, what I do with my hands and what I see with my eyes is going to be completely different from what you do with your hands and eyes. With how you're holding the torch versus how I hold the torch is completely different. But like you said, whatever works for you is what works, and build on that.
There are guidelines and good procedures and policies and concepts and all that to get you started, but you eventually find your own things that work, and they may be completely different than what textbooks and American Welding Society codes and all that recommend. And one thing that comes to mind is watching you weld, Rush, where you're feeding wire most of the time, just how it's comfortable from sort of the side of the puddle. There would be a lot of people that would say that's not the correct way to do it. The results are pretty hard to argue with. Now, you can do it wrong. You can feed wire in out the side of the puddle and have little trailers of unmelted wire coming out of the puddle if you do it wrong, but you're not doing that. That's just the way that works for you, and not a thing wrong with it at all. So that's just an example of find what works for you and perfect it and move on.
When I feed, I like to feed from the side, but it's still to the front of the puddle.
Yeah.
it's still going to the front of the puddle, because if you are too far to the side of the puddle, I mean, it's not much difference. It's only like less than a 16th inch of difference, really, that you can be from the point of keeping the weld proper to it. You're pulling out these thorns out of the weld puddle to the side. But I like to do it that way because I can see each side of the weld and see where I'm going, and I can see how the weld is melting in, and I can see everything from that perspective. That's the way I like to weld.
It obviously works for you. And if you think about if there was a third side to that joint, where you couldn't feed from the front of the puddle, what are you going to do there? So it just, like you say, it works for you really well. And I'm just remembering giving some welding tests on some regular fillet welds, vertical uphill. The guys were just in the habit of feeding from the side. They'd rest the wire on their shoulder, a full length of TIG wire, and pull in and out of the side of the puddle. And just, it was like you said, it was leaving a row of thorns and up the side, and they didn't think that was a problem, So it could be done that, even on those light gauge fillet welds like that, but it's just, if you're going to do it, you have to do it right. That's all. You still got to feed to the front of the puddle and feed in a way that you don't have unmelted trailers of wire coming out. But I'm getting off on a tangent on that. That's just an example of find what works for you and make it work.
Yeah, and talking about wire again, what size filler wire do you use for those outside corner joints on those look like shroud covers of some kind?
Typically it's just, I stick with 16th.
I'm right there with you.
Most of those are 16th inch, 40-43. Typically, whatever my metal thickness is, the closest rod size that matches that material thickness is usually a really easy, straightforward way to go.
I always think it's a pretty good rule of thumb to try not to go thicker with the filler metal than the thickness of the metal that you're welding. Now, that obviously changes when you start doing multi-pass welds on 3/8 thick or half-inch thick. But if we're talking about sheet metal, if you're welding, say, 40 thousandths, a 16th filler metal sometimes is a little bit big. Draws a lot of heat out of the puddle when you dip it in. And so, going with a 045 wire might be a little bit better.
So what kind of stuff do you like to do outside of work? Typical welder.
Yeah, more words. More work.
There's other stuff out there besides welding?
I do like doing photography and going out to eat.
Yeah, we always really like your video editing and stuff like that. It's always fun to see how you put all that stuff together and come up with something.
That's something I have a lot of fun with too. I guess I wasn't putting that in the mental compartment of outside of work since it's post work. I'm still looking at work when I'm doing it, I guess, but that's fun. I like doing the video editing, to be able to take different things and mash them together.
It takes you a lot of time to do that stuff, though, doesn't it?
I've spent up to 3 hours making a Instagram video. They're pretty fun. It's something that I always thought would be cool. Like, hey, I want to see a welding video like this. That was my initial thought. And then I was like, you know what? I want to have a welding video like that, but I want it of me. I even asked a couple people, like, hey, do you think you'd do this? And they're like, no way. I was like, all right, I'll figure out how to do it myself.
That you did.
Everything's done on my phone. Just recorded and edited off my iPhone.
Well, I think that's probably a pretty decent place to stop, and we just want to thank Rush for taking the time and talking with us this evening. It was really cool hearing all of your ins and outs and stuff.
Well, thanks for having me on. It's good talking with you guys.
Anyone else have anything they'd like to ask Rush while we've got him on the phone?
I think I'm spent.
And where can we find you? Where can anybody find you if they want to get a hold of you for any reason?
I'm on Instagram as Kane Kid, KANEKID. I have a Facebook welding page, Rush Kane GTAW. You can contact me through my email at orders@rushkane.com.
All right, you heard it. So make sure to order some rings. All right, well, thank you, everybody, for listening to us, and thanks again for Rush for joining us. If you'd like to get a hold of the podcast, our email address is Welding Tips and Tricks Podcast at gmail.com. You can also give us a phone call and leave us a voicemail at 915-308-7024. And I'm Roy Crumrine. You can find me at crummywelding.com.
I'm Jody Collier. You can find me at weldingtipsandtricks.com.
And I'm Jonathan Lewis. You can find me at superiorweldedfab.com.
This is Rush Kane. Instagram is KaneKid. That's a wrap.
She said your nickname in welding school was Long Arc.
Long Arc.